Hello children, I am from ARIHANT College of Education. My name is Trishna Parmar and our today's subject is Science for Standard 6. So before we start with our today's topic, let us see how much you remember from your previous year. Okay, so let us begin. What are the solid, liquid and gaseous state of water? I know you all remember this. So it should be the solid state is ice. The liquid state is water. That's the flowing water. And the gaseous state is water vapors. Very nice, children. Now I know you all remember this. So now we will go ahead and watch a small video. I hope you all enjoy that video.
Wax is used to make many things, most usefully candles. Let's take a candle and light it and observe what happens to the wax. We need a candle, some molten wax in a small plate or a bowl, and a matchbox. Take a candle, fix it on the table or a stand. Light it and keep it lighted for some time. If you look at the candle now, you will see that the candle has changed its size. Now take a spirit lamp, light it, put a beaker, chop some wax off the candle and heat. Remove the spirit lamp and let it be for a few minutes. You will see that the wax has regained its original shape.
I hope you all enjoyed the video. So before talking about the video, children, I would like to add something. Conserve water. Whenever it is not necessary, please turn off the taps. Do not let the water flow just like that. This will reduce the water shortages which we are having now and which is a very big problem. Children, avoid throwing plastics or any garbage in the water, in your tanks or near the riverbeds or whenever you go on the beaches or anywhere. Keep your surroundings clean. The protection of your environment is very important because we are going to live in this environment. We need to breathe fresh air and keep ourselves healthy. So, water contamination is a bigger problem right now. So, we all need to come together and help our environment to protect it. Okay? Welcome back, children. I hope you enjoyed the video. So, what was the initial state of wax? Correct, it was in solid state. And how did the pieces of wax change? Correct, it changed due to the heat it gained because of the spirit lamp. And how did it get converted into? What did it get converted into? Liquid state. So children, if you observe over here, when wax was in solid state, when heated, it turned or converted into liquid state. And what will happen when wax cools down? Correct. It will change into its initial state, which is a solid state. So children, you can see in the first image a liquid state of wax. And in the second image, you can see a solid state, a hard state of wax. So when any substance change from one state to another state, that process is called the change of state of the substances. So here we come on our today's topic, substances in the surroundings and their properties. Substances in the surroundings and their properties. The state of substances changes when heated or cooled down. So every substance in our surroundings is found in either the solid, liquid or gaseous state. We just now saw an experiment of wax. So when it was heated, the solid state converted into liquid state or changed into the liquid state. So you know that whenever any substance is heated or it is cooled down, the state of their substances changes. Now scientist J. Willard Gibbs in 19th century said, the characteristic properties of a substance depend on its physical state and arrangement of particles in it. So this statement states that the properties of a substance, so the physical state, you can see that this is my cell phone. The physical state of the cell phone is solid. Okay, so the characteristic of properties of substance depend on its physical state. So whatever the properties of my mobile phone is depends on its physical state. It is solid. So there will be some properties of solid also. So let us see with the help of a chart. So properties of solid, liquid and gaseous. The property of solid mass is definite. Liquid is also definite and gaseous is also definite. The shape. The solids have a definite shape, but liquids acquires the shape of the container and gases also acquires the shape of the container. So if you take a glass of water and pour it into a bottle, so the water will take the bottle's shape. Same way, the gas, when you blow a balloon, if there is a heart-shaped balloon, it will take a heart. If the air will go inside and the balloon will be blown in a heart shape. If it is a round, then the balloon will blow in a round shape. Correct? So that's how the substances like the gases or liquids acquire the shape of their containers. The solid's volume is definite. The liquid's volume is also definite. So whenever a solid is kept anywhere, it has the same shape. The volume does not change. Liquid also, the volume does not change. It is definite. But for gases it is indefinite, because if the pressure of the gases changes in any container, the volume of the gas also changes. So these are some three properties of solid, liquid and gases. Heat and change of physical state. Children, observe the below image. You can see that ice, when it is heating, it turns into liquid state. When it is heated more, it turns into water vapors. In the same way, you can see the down arrow going towards your left hand side, correct? So when the vapors cools down, it turns into liquid state. And when this liquid cools down more, it turns again into ice. So we can see that the change in the state of substances depends upon the heat gained and heat lost. This is what we saw with the wax example also. So now I want to ask you all one question. Whenever we keep a bottle of water in the fridge, does it turn into ice immediately? Or when we keep the water on the stove, does it immediately turns into water vapors? No, right? It does not. So there is a specific amount of heat gained or lost. That time, the state of the substances changes. So how do we come to know that the substance is hot or the substance is cool or the substance is very cold? So for that, we have a next point, the temperature and the thermometer. So with the help of the temperature, we know that a substance is hot or cool. And with the help of a thermometer, we know that what is the temperature of that particular substance. So let us see what are the definitions of the temperature and the thermometer. So Temperature is the physical quantity which judges the environment whether it is hot or cold. So in the summers, you know for the entire day it's very hot. But you also realize when it starts becoming evening, it starts cooling down, the temperature starts dropping. Correct? So that's a physical quantity. You can judge from the environment if it is cold or hot. A thermometer. Now, it is a device which is associated with the temperature. That is, it is a device to measure the temperature whether it is hot or whether it is cold. Now, the unit of measuring temperature is degree Celsius. So make sure, children, you write like this, a degree Celsius. This is called as a degree Celsius. Okay. Now, if you have seen the old thermometers, you can see that there is a silver color lead finial. So the bulb at the lower end is filled with mercury. So that bulb which is filled at the lower end, it is called mercury. This mercury rises in the capillary tube. It tells us the temperature of the substances. So whenever we keep this thermometer in any substance, or if we keep it in a hot substance, it tells us the temperature of how hot it is. If we keep it in ice, it tells us how cold it is. So now let us watch a video where you can note down the temperature to thermometer, and it will be a good exercise for you. So you can know how the thermometer readings are taken. I hope you all enjoyed the video. So in this video, you have observed that there are three states of water. First is ice, second is lukewarm water, and third is hot water. So when the thermometer was dipped in the cold water, the temperature was 0 degrees Celsius. When the thermometer was put into lukewarm water, it was 47 degrees Celsius. And when the thermometer was put in the hot water, the temperature was 80 degrees Celsius. So see the difference of temperatures. Okay. So when it is cool, the temperature is low. When it is little warm, the temperature rises. When it is very hot, the temperature rises to 80 degrees Celsius. So there is a change in the temperature. This is measured by the thermometer. So we need thermometer to measure the temperature. Correct? Nowadays there are several types of thermometer, and digital thermometer is one type of it. You can see this digital thermometer even at your place. So children, if hot water has a temperature of 80 degrees Celsius, the boiling point of water will be how much? It is 100 degrees Celsius. So the boiling point of water is 100 degrees Celsius. So we will now see what is the boiling point. So children, when water is spilled on the floor, what happens? I know we all go and immediately wipe it, but if you just keep the water on the floor, the water starts to dry up slowly. So this evaporation takes place at the surface of the water. But what happens when the water boils? When water kept on a stove attains a particular temperature, then evaporation takes place in all parts of the body of water. The water bubble rising at faster and faster rate to the surface is called boiling water or ebullition. If you see in the image, when the water is boiling, then there is evaporation taking place. You can see all this evaporation taking place. Now when this evaporation is taking place, there will be little bubbles which is coming, right? So when this bubble rises more, like they are very faster and faster there when they are coming to the surface, that time you call the water as the boiling point of water or ebullition. At the same time, when this water vapor cools down, it is converted into water again. So this water vapor is going on. So they are converted into water vapor. But at the same time, when this water vapor cools down, it gets converted into water again. Then this process is called condensation. See at the image, see this water is ice. So now when this is cooling down, when this is getting converted or when this is coming to a normal temperature, this begins to convert into water again. So this is called as condensation. Now at the sea level, the water boils at 100 degrees Celsius and condensation of steam also takes place at 100 degrees Celsius. If you observe, if you see any article or if you see any video, so at the sea level, just imagine the water boiling at 100 degrees Celsius and the condensation. So when the water gets converted into water, when the water vapors, when the water vapor gets converted into water, that also process takes place at 100 degrees Celsius. Hence, boiling point and condensation point of water are same, that is 100 degrees Celsius. Now let us see what is a freezing point. Freezing point. So I asked you one question before starting the temperature and the thermometer. When we keep water in the fridge, does it immediately become cool? No, right? It takes some time to become cool. So children, when you keep water in the fridge, the water becomes cooler and cooler and cooler. But it comes at a stage where the cooling stops and the water starts to freeze. So the temperature at which water starts freezing and forms ice is called the freezing point of water. So if you keep a bottle of water in the freezer, inside the freezer, the water will start becoming cool and cool and cool. But at a particular time, it will start changing into ice. It will start converting itself into ice. So from that point, it is called as freezing point of water. The temperature of substances falls below 0 degree. So as we have seen that the temperature of the ice was 0 degree Celsius. So when you put a thermometer in the ice, the temperature falls to 0 degree Celsius. So for example, if you check your refrigerator's freezer, the temperature is around minus 18 degrees Celsius, not plus 18 degrees Celsius, okay? It is in minus 18 degrees Celsius. That's the reason the water starts to freeze, because the temperature is in minus 18 degrees Celsius. When ice melts or changes to liquid state, the temperature is 0 degrees Celsius. Now we have seen ice, when you keep it outside, when you bring the ice cubes outside, it starts to melt. It starts again becoming in the liquid state. So that time when the ice is changing into water, the temperature is also 0 degrees Celsius. Hence, the freezing point and the melting point of water are same, that is 0 degrees Celsius. So when the water is freezing, when the water is getting freezed or it is getting converted into ice, that time also the temperature is 0 degrees Celsius. And when that ice cubes is converting into water, that time also the temperature is 0 degrees Celsius. So hence the freezing, sorry children, so hence the freezing point and the melting point of water are the same, that is 0 degrees Celsius. I hope you all understood the freezing point and the boiling point. Now various uses of changes in physical state. Candles are made by melting paraffin wax. So without melting the paraffin wax, the candles cannot be made, they cannot be molded into shapes. Solid carbon dioxide, that is dry ice, is used to make ice creams and keep it frozen. If you see over here, these are used to make ice creams, and it is also used to freeze the ice cream. Liquid nitrogen is used in animal husbandry. So there are a lot of medication or medicines which needs to be kept in liquid nitrogen, so it does not loses its importance. So this is how liquid nitrogen looks. So liquid nitrogen is used in animal husbandry. Sand, silica, is melted to make glass. I think children, you must have seen this. So this is silica. Okay. Now this needs to be melted, so we get glass. So glass cups, glass ornaments, or anything, whatever we need to make from glass, or we want to make it as a glass, we need to melt silica. That's how we get glass articles. Metals like gold and silver are melted to make ornaments. Now you must have seen gold, silver ornaments like earrings and jewelry, bangles, chains. Now how these all are made? These are all metals. So these need to be melted so that these ornaments can be made. And iron is also melted to make tools. So till the time we don't change the physical state of these substances, we will not be able to make any articles or any other substances from it. So remember children, whatever we do, if a substance, we need to change the state of the substances. So for iron, like we need to make screwdrivers. So we need to melt iron to make a screwdriver also. So we can get that particular shape. So the changes in physical state only takes place when a substance is heated or cooled down. Now, our last topic is sublimation. Now, what is sublimation? The change of solid substances directly into gases or vapors without first changing to liquid is called sublimation. So from the starting we learned that solid, when it is melted or when it is heated, it changes to liquid, and when liquid is more heated then it changes to gases. But in sublimation it is not like that. The solid directly changes into or converted into gases or vapors without first changing to liquid state. Remember this definition. Sublimation is a process where the change of solid substances directly into gases or vapors without first changing to liquid. Okay? Now, iodine crystals do not melt on heating but directly changes into gaseous state. Now, some examples are camphor, incense sticks, naphthalene balls. You have seen this all in your home. They are very useful. So, incense stick near your temples, on your small mandir, you go ahead and you lit an incense stick, right? So that is also in a solid state. But when you heat it, it gets converted into gaseous state. It does not melt, but it directly gets converted into gaseous state. In the same way, naphthalene balls. They are white color balls. They are kept inside the cupboards so the damp smell does not come. So these balls are also solid in state, but they do not turn into liquid first. They directly change into gaseous state or water vapors. So if you see an image over here, then in this there is a tripod stand. We have kept a beaker with iodine crystals in it and a water vapor. Okay. So now if you observe, when these iodine crystals are heated, okay, so there is this dark grey color iodine sublimate which forms over here, and these are purple iodine vapors. So children, this does not immediately turn into liquid. They do not go into vapors. They do not go into a water state or liquid state, but they change into vapors and they stick to this beaker, right? So now we will watch a small video which will help you understand the concept of sublimation more clearly. So let us watch a video.
Sublimation. If you keep naphthalene balls exposed to air for some days, it is observed that their size gets reduced after some days. This happens due to a phenomenon called sublimation. Normally, solids transform into liquid on heating, but in sublimation, a solid gets directly transformed to a gas on heating or on exposure to air. In above case, as some mass of the naphthalene balls is converted to a gas, they get reduced in size. There is a simple experiment to study sublimation. Some ammonium chloride is taken in a china dish and a glass funnel is kept inverted on it. A cotton plug is inserted into the funnel and the china dish is slowly heated. It is observed that ammonium chloride on heating gets directly transformed into vapor. Also, the vapors get cooled on the glass surface and are converted into solid form. Thus, we infer that ammonium chloride undergoes sublimation and hence is converted into vapor form directly. Also, the vapors when allowed to cool directly get transformed into solid state.
I hope you all enjoyed the video and understood the concept of sublimation more clearly. So children, tell me, when you open a packet of camphor, this smell immediately comes up or you immediately smell it. Why? Now I want you to do this exercise. Okay? Now our conclusion part. So today we have studied about substances and their properties. So we studied two properties, that is boiling point and freezing point of a substance. Correct? And how the substance change from one state to another. So when it is heated, what happens to the substance, and when it is cooled down, what happens to the substance. I hope you understood it clearly today. Now let us do a little recap. What happens when substances are heated or cooled down? The substance, when heated or cooled down, change from one state to another state. Now Ria pours some water from her bottle into another bottle. Does it change the shape? Yes, of course. The water takes the shape of any container in whichever it is poured into. So, if Ria takes her bottle and pours the water from her bottle into another bottle, the water will take that bottle's shape. So, yes, the water will change its shape. Now, the third question is Halima picks up a small stone and from the ground and puts it in the water in a dish. Does the shape of the stone changes? No, the shape of the stone will not change because the stone is solid. Correct? The solid does not change its shape. Now the last question. I am bound in a thermometer. I measure your temperature. Who am I? I all told you to remember this, and I know you are remembering. So, who am I? I am Mercury. So, Mercury measure our temperature. So, children, please fill in the Google form. The link is given in the description. Okay? Click on the link. You will immediately go on the Google form. Fill in the questions based on today's topic, that is substances in our surroundings and their properties. And mark the correct answers. I know you have understood. I hope you have understood the subject today or the topic today. Now today's homework. Write solid, liquid or gases in each of the brackets. Now you know this is from your textbook, the question number 1. On a bright sunny day, Ria and Gari are playing with a ball. There is a bracket. You need to mention what is that ball. What state is that ball in? Ria brings tender coconut water. Dash brackets for her. So now what is coconut water? Which state is coconut water? At the same time, a strong breeze starts blowing. Now we all know when strong breeze starts blowing, what is blowing. Okay? And it also begins to rain. So it also begins to rain. So rain is water. They run back into the house. So house is something which is hard. They change their clothes. Clothes is also something have a definite shape, right? And then their mother gives them a cup of hot milk to drink. So a cup and hot milk. So you should know a cup is hard and hot milk is flowy in nature. So please fill in the brackets with correct state of substances. Okay? Now let's move on to the next question. Sublimation. Write the names. What is sublimation? Write the names of everyday substances that sublimate. I have given you many examples, students. You also make sure that you write everyday examples of sublimate. And write what is sublimation. Now question number 7. Who am I? I make things hot and cold. I dissolve in water but not in kerosene. You have to find out who am I. And question number 8, why does this happen? So children, why does this happen? Coconut oil thickens in winter. B. Kerosene left open in a dish disappears. The fragrance of incense sticks lighted in one corner of a room spreads to the other corners. And there is an image given. What do you see in the picture? Please write down what do you see in the image. There is an apple and there is a balloon and there is water. So now I want you to write down this. What happens? Okay? All questions are from your textbook. Please use your textbook or refer your textbook to answer your questions. You will find all the answers in your textbook itself. And complete your homework. Okay? I hope you all enjoyed this session. Thank you so much, children. Have a wonderful day.